everyone, and welcome to today's webinar, Wireless, Revolution or Revolt. Your presenters today are David Procter from Sensoteq and Stuart Walker from Reliability Maintenance Solutions. And today's session is brought to you by Reliability Connect. I'm Jenny Smith of Mobius Connect, and I'll be the moderator for today's session. Before we do get started, I'll just review some important information with you. Today's webinar is being recorded, and you will be emailed a link with access to the on-demand version of the webinar tomorrow. The recording of the webinar will also be shared on Reliability Connect, so feel free to pass along to your colleagues if they were not able to join us today. Before we start, I do want to tell you a little about Mobius Institute. Mobius Institute is a worldwide provider of reliability improvement and condition monitoring education dedicated to supporting plants and helping them become safer and more successful. Mobius Institute's key advantage is its unique training style that features innovative 3D animations and software simulations, making complex topics easier for you to understand. The Mobius Institute Board of Certification is an ISO-accredited certification body that provides globally recognized certification to CBM practitioners and reliability professionals at any stage in their careers. To view the global training schedule, go ahead and visit mobiusinstitute.com. Next up, I'm pleased to share with you about the Mobius Connect community platform. The Mobius Connect community is all about you, providing you with the space and technology to connect with the right people and resources to help you solve problems, continue learning, and share your experience too. Once you've created your free profile, similar to how you would on LinkedIn or any other professional networking site, you can start connecting with other industry professionals wherever you are in the world in any language. Mobius Connect does include some fun features like the industry's live feed, forum discussions, an interactive connection finder map, direct messaging, and customized communications that are based on your areas of interest. We also have global events, jobs, and news listings, all along with a mobile app. You can also continue your educational journey live with our Connect conferences or online with our Connect knowledge base, or you can become a member of your regional Community Connect group to gain access to additional resources and attend live or virtual meetups with professionals from your area. To get started with all of this, you can create that free profile and join the community at mobiusconnect.com. And last but certainly not least, today's webinar is produced by Reliability Connect, the leading online educational community which is published by thought leaders and experienced industry professionals from all over the world with a dedicated focus on each of the reliability improvement technologies. Reliability Connect allows you to organize content based on your areas of interest like asset strategy, condition monitoring, continuous improvement, defect elimination, implementation strategy, data analytics and IIoT, leadership, precision and proactive skills, and work in spares. You can get started on Reliability Connect by creating your profile on Mobius Connect and selecting which of those technologies you'd like to stay up to date with. You can also visit that website, reliabilityconnect.com, directly so you can access some of those on-demand webinars, interviews, videos, white papers, and much more. Furthermore, if you are interested in contributing to the Reliability Connect knowledge base, please reach out to us during the webinar through your question panel, and we'll be happy to share more information with you. Now, it is my pleasure to introduce today's presentation, Wireless, Revolution, or Revolt. Your presenters today are David Procter and Stuart Walker. David and Stuart, are you there with me?
Yes, we are.
Perfect. Thank you so much for being here with us today. And if anyone does have questions for these gentlemen throughout the presentation today, please type them into the question panel on your GoToWebinar screen. And at the end of today's session, David and Stuart will be more than happy to answer some of those questions live. Your questions do get answered on the air anonymously, so no need to worry about getting called out. And if we do run out of time and don't make it through all the questions, they'll reach out to you directly after the webinar to get those questions answered. All right, guys, I'm going to go ahead and pass this presentation your way so that you can get started for all of us.
Okay, hopefully everyone can see my screen. Welcome to today's webinar, Wireless, Revolution or Revolt. And the title really came up whenever chatting with Stuart and some of my colleagues about how do we really get the conversation started about some of the newer technology that's come on to the predictive maintenance and condition monitoring scene in the last probably 4 to 5 years, and really, is it a revolution or is it a revolt, and are people not liking it? So we want to ask those questions and find out everybody's thoughts on that. So we're going to run through some points about the wireless technology. Stuart and myself are going to have a discussion around those points, and then we're going to go into some case studies that highlight some of the benefits of wireless tech. So first of all, my name is David Procter. I am the product manager here at Sensoteq. It's my job to make sure that our products are meeting the needs of our customers and listening very closely and working with the industry, which we have done with RMS. Stuart?
Yeah, great. Yeah, so thanks, David. My name's Stuart Walker. I'm one of the directors at RMS, and I've been heavily involved with condition monitoring, reliability for 25 years now. We set up RMS 22 years ago, and yeah, we do a lot of service work. We're out there in lots of different industries, product solutions and training, and the last few years I've been heavily involved with getting some of these newer technologies, not just wireless, but some other technologies out there into industry, which I've really been enjoying. So yeah, there's a little intro about me.
Excellent. Thanks very much, Stuart. So on to the first question that we have. What is predictive maintenance? And I've put in a quote here that I actually heard from a maintenance manager in an automotive plant in America a number of years ago, which is, if you don't plan your maintenance, your machine will plan it for you. And that's always stuck with me throughout the journey, learning more about predictive maintenance over the years. Stuart, from your point of view, how would you define predictive maintenance?
Yeah, I mean, if I go back, probably more sort of 26, 27 years, I remember working at a plant where we had no condition monitoring or predictive maintenance, and we basically run to failure on a lot of the equipment on site. So we had no condition, no data to look at. These machines was just when they broke down, we fixed them. Off that, we then progressed a little bit onto preventative maintenance, where we'd basically plan every year. We might change a set of bearings on a machine, and again, not very cost effective. And then progress from that really through technologies, vibration analysis, oil thermography, looking at basically collecting data and then predicting really when machines are going to fail. I mean, it's very difficult you're not going to be able to say it's going to fail at 2 p.m. on a Sunday, but you can certainly see the trend data, the data coming in, and you can make an informed decision off that data. And then the work's planned in at maybe the next scheduled shutdown or event, basically. And yeah, that's been done for many years now, and it works well. It works well. You'll never catch 100%. There's always going to be instances where something might happen that quite quickly can lead to a failure. But again, some of these newer technologies, which we're going to talk about today, are going to allow you to maybe get a bit of more of an insight more often. So yeah, that's predictive really, David.
Yeah, great. So it's repair your machines before they fail, really. It's excellent. And in terms of the process around that, this is my probably relatively naive view of it, but I've always seen it as, through some means you have to measure the vibration, then you get that information, that data, to someone who's actually going to do the analysis, and then it's their job to understand that data and make a recommendation as to whether or not that machine needs repaired or what part of that machine needs repaired. And the way I see it, it's the same whether that's through, said wired here, I'll talk about that in a second, but whether it's wired or wireless, I think the process is the same. So yeah. On the wired approach, well, what does that mean? Well, there is, I guess, what we might call a traditional method of capturing data. So condition monitoring. And Stuart, could you maybe give us a bit more detail about what that traditional method is, the route-based?
Yeah. So it varies site to site. I mean, there's quite a few sites now that have got internal reliability teams where they're collecting the data on site. So let's just talk vibration for a minute, maybe with a vibration analyzer, and they'll have different routes set up. Now, a lot of balance plant equipment probably done on a monthly basis. They've probably maybe got some more critical plant that's maybe done weekly even. Some of the super critical will probably have some sort of monitoring already on there, maybe some sort of online. But if we talk the balance of plant, which a lot of people do and on different plants, I would say a common period is probably once a month you're collecting that data, which is quite amazing really, because if you think you're on that machine for sort of a minute collecting a number of measurement points and then you're not seeing that machine again for a whole month, a lot can happen in between there. There's different process variables. So, but it does work. It does. Over the years, we pick up a lot of faults. But like I say, if you've got some sort of lubrication issue or something that the process changes and it occurs quite quickly, you are going to miss some of the events basically. But that's quite traditional, and that might be a service company as well, going out to different sites, collecting data.
Yeah. And I suppose there's been an evolution of that technology. One of the things that always stuck out in my head was my granddad used to be in the Navy, and he would tell me about getting a screwdriver, up against the ear, and then the screwdriver up near the bearing of a motor. And
I still do that, David. I just make sure nobody's watching. No, it's a good point actually. It's your own sensors as well on the machine, the touch feel as well, which I know we'll draw on that later on.
Yeah, exactly. And I guess the point is that technology is always evolving, and it really is there to help make sure that what your end result is happening either better or faster, whatever the outcome actually is that you want. So on to that, what do we actually mean by wireless? So from our point of view, wireless is actually a relatively generic term these days that probably covers more than just the data transfer method between a sensor and some system to do the analysis tool. I've broken it down here into, you have a battery-powered device, and actually that's quite a large part of the enabling technology behind this revolution, as it were. So you have a battery-powered device, and then you have some method on that sensor, that battery-powered sensor, to capture either an acceleration or velocity signal or something like that. So some sort of vibration signal is being captured on that device, and then that data is being wirelessly transferred through to a control system. So that's where the wireless term comes in. I've shown here cloud-based analysis, and that's actually because with the wireless revolution has also come, sort of just by the nature of it, this other technology, which is cloud-based connectivity to these devices. And for those who don't know, I'm sure everybody knows what the cloud is nowadays, because you hear all about it every time you boot up Microsoft products and things like that. That's all cloud-based now, but it's really just a web server that's there storing data and maybe communicating to some devices. But there's actually no need for that specifically to be a cloud server. It could be something localized as well. But when we talk about wireless, really it's this whole new ecosystem of battery-powered devices transferring data through to some sort of centralized, controlled system. And one of the questions I get whenever I chat to some technologically sort of advanced customers is, why is it only in the last 5 years that wireless seems to have broken into this particular market? And I say to them that whilst wireless technology and battery technology and cloud technology has been there for longer than 5 years-ish, it's actually only in the last 5 years that the technology has become either affordable, readily available, and actually up to that maturity level for all of those items of the technology that really enables it to become this small, sensorized product with these sort of interesting interfaces to analyze the data around that, particularly with the battery technology, but also with something called MEMS technology. And the advancement in the MEMS, which are micro electromechanical systems. So that MEMS technology has advanced quite a lot in the last few years, to the point where we can now measure higher acceleration signals, and that has enabled those battery powered devices to actually become more powerful in that regard. So previously measurement ranges were quite low, but they've now increased up to and over the 10 kilohertz range. Why is this important? Well, Stuart, I don't know if you can give us some insight into that.
I'm just going to jump in there, David. For us, this was a massive point, really. The frequency range you're looking at is so important, and you've got to be really careful with these systems, because that frequency max that it's looking at, if you're looking really quite low end, let's just say we were looking at 1 kilohertz, then you're really only going to be looking at sort of the machine, the velocity, sort of things like unbalance, looseness. This is a bit crude, but sort of the machines you put your hand on and you feel the vibration, those higher frequencies that bearings are generating, gears, you wouldn't even see them with the sensor. So you could literally have let's say a fan that's got a cage defect or something like that on the bearing that's about to fail, but the actual velocity levels coming off the sensor, because it's only measuring to 1 kilohertz, is saying I'm fine. And then suddenly the fan fails and they say, well, why didn't it pick that up? Or at worst case, it's going to pick it up in the last sort of few minutes or an hour just before it fails. So for us, having that large frequency, high range was key, really, absolutely key for this technology. And I think that for us, as well as the battery technology and the communication, but for us, having that comfort factor that you know the sensor's looking where you want it to look, basically, that's quite key.
Yeah, exactly. And one of the things we've heard from, again, sort of vibration analysts across the world is it actually opens up a wider range of applications, which means that they can now, before they were comfortable putting it on lower speed or normal speed fans and pumps, but then they start to go, actually, now I can stick it on gearboxes, and that means I can cover quite a wide range of machines across my plant. Which brings us quite nicely on to the next question, which is why actually use the wireless technology at all? And the first point that I have listed here is accessibility. What do I mean by that? Well, I think that the wireless technology has actually reduced the barrier of entry for condition monitoring for a lot of people by making it quite an affordable method of monitoring quite a wide range of machines. And that affordability itself means that people who maybe weren't looking at it before are now looking at this technology, making it more accessible for them. It also means that you can acquire data that maybe you wouldn't have been able to before if a machine always is running as part of a batch processor, for example. You know, if you're doing route-based measurements, you wouldn't be able to, you sometimes have to turn the machine off to remove the guard and then stick your piezoelectric sensor on it and then take that measurement. But now you can fit the sensors and leave it whilst the machine's running 24/7, if that's the case. I'm sure you've seen this, Stuart.
For what I see a lot on sites, David, and I see it more and more with sites, is a lack of resource, really, being able to collect the data traditionally. So some of these, even though we've got really fast analyzers now, some of the sites you go to, we do many, and you might be doing in a couple of surveys like over 500 assets with probably 8 to 10 points per asset. There's quite a time to do that, and a resource to put someone out and to do that. And like I say, remember what I said before, a lot of these typical plants, you're only getting data there once a month, let's say, and you've had to spend quite a lot of time getting that data. So, yeah, for me, what I'm hearing back from a lot of industry is, yeah, one of the benefits is that we don't have to go out and collect that data in the first place. But then you've also got the benefit of, because it's collecting data a lot more often in minutes, every few minutes, then you really get a real detailed insight into the machine. So if we've got process issues affecting the machines, we're going to probably see that on the data. And if we have a fault that's got quite a short P2F curve in terms of when it initiates to when it fails, you've got a higher chance of seeing that with the wireless data, where, like I said, traditional vibration, it works really well, but I do think normally there's about probably 20% we probably won't pick up with the traditional because the faults just happen too quick, or there might be some other event.
Yeah, and that's sort of the point that I was making with the reactive comment on the PowerPoint slide, which is the fact that the system's always monitoring. You're always looking at what's happening on these machines. So your reaction time, you can actually react whenever something happens, as opposed to after something has happened. Now, obviously, we hope with predictive maintenance we can always capture something beforehand, but you don't always know that.
Yeah. I mean, I saw one recently, actually, on a wireless one where a bearing had been over-greased and the temperature reading showed it brilliant. It basically increased and it didn't drop down. It normally, with the data, you normally see it drop down after a few hours or a couple of days. The temperature will rise and fall. And this, you could see it just been over-greased. Yeah, it just gives you good for sort of root cause as well. Why is suddenly this bearing at 80 degrees and it should be at 20, and you've got it in the data. So it's good for that as well.
Yeah, and actually temperature is one thing I always sort of, you get almost for free in a way, because all the sensors have temperature capability in them. We always talk about vibration as the most interesting thing, but actually temperature is such a key indicator of other things that are going on with the machine.
Yeah, no, definitely.
Yeah. From a coverage point of view, one of the things that I find interesting, whenever Sensoteq started our journey, we were initially going on mostly critical assets across plants to get our customers comfortable with the technology. But actually we found that more and more so, a lot of customers are now wanting to roll it out across their plant because they see the benefit in, I guess after the pandemic was actually a real highlighted for them that actually you don't know if you're always going to be able to be at site, because so many people are working from home now. So coverage of a wider range of machines gives you eyes on all the time.
Yeah. Another jumping in there, David. Again, I was at site the other day, and batch process machines. This is a great application for it, where they might only run for a few hours, different times a day, maybe even only a couple of days a week. And normally when you're trying to capture those machines, unless you're in on that day or you can time it, it can be quite difficult. So batch machines, offloading pumps where tankers are coming in and offloading for short periods, then the machine's off. This technology is fantastic for capturing those, because it sits there waiting to sense, am I running, and then starts collecting the data. So had some good use with that technology.
Yeah, and of course, there are times when maybe using wireless sensing isn't actually appropriate as well. I guess the Revolt side of the title, as we have it. So there were initially some limitations on the technology in terms of battery life and measurement range, which we've discussed, but also transmission range between the sensor and the receiving device. But actually that gap, it is getting better, and it is closing the gap between some applications where root base was definitely required before. But, you know, we were chatting yesterday about this, Stuart, how there's still a need for that traditional root base measurements.
Oh, definitely. I mean, I think at the minute with the technology, I think wireless is fantastic for a lot of balance of plant equipment, pumps, fans, gearboxes. But if we start looking at really specialized applications where we might have like really slow speed, like 1 or 2 RPM, and I want to do special filtering and variant analysis techniques. I'm sure that's going to come with the technology, but you're going to need quite long time periods to collect this data when the machine's only running at 1 or 2 RPM and you want to catch 3 or 4 revolutions. At the minute, that data for the wireless is not really going to work, but I'm sure down the road that'll improve. So yeah, there's definitely specialized applications, run-up, rundowns, and doing all these transient resonance problems, phase. We need to get on the machine with an analyzer. So really, the wireless is not designed for that. So it's certainly not, you go into wireless and then your analyzers are just thrown to the side. Not by any means. I think for us as well, the wireless is great for giving you that trigger, that initial insight, but then you'll go down on the machine. You've got to go have a look, because what if a bolt's come loose or something, and that's why you've got to raise vertical 1 times vibration or something. You've got to still get down there and see it. And I think my only concern with out there, I see a little bit, is there's sometimes a bit too much talk of just throwing a load of sensors on, walking away and never seeing that machine again. And I think that's a bad idea, to be honest.
Yeah, and there's so many other technologies as well. Motion amplification, I know that's something you're very hot on all the time. And
yeah,
you still need to have that learning element as well, don't you, of teaching the people at the plant how to look after their machines and what bits to look after. And, you know, it's all part of an ecosystem, as I see it, this wireless technology.
Yeah, no, definitely. I mean, for me, it's when it's used in the right place, the wireless is absolutely fantastic. And I know we're getting some case studies later, but yeah, I mean, I've had a couple where I'm talking to a customer. I was looking at one today, actually. We have a little alarm come in, and I'm a 3-hour drive away. But I'm sat in my office, able to just have a look at his machine, give him the comfort pack, saying, yeah, no, nothing to worry about, just keep running. And that's amazing, that. You sort of have to pinch yourself a bit, because years ago, I'd have probably been still driving there now to go see it, and I can have a quick look. So, yeah, it's quite amazing, really. It's, yeah, I'm enjoying using it, actually. It's good.
Good. So that's the wireless aspect of what we were talking about before, but we did mention the cloud, and there are some additional benefits that we get from bringing the data up to the cloud. I will obviously say that it doesn't just have to be wireless sensors bringing data up to the cloud. There are wired solutions out there as well. But I guess one of the big things that you get utilizing the cloud is that you get these quite large data sets, because you can be capturing data up to every minute in some systems, and that ability to look back a year ago and see what was happening in the plant for the same day but a year ago, just is such it's a different sort of insight that you're getting to the data. Obviously you get long-term trending with route-based measurements as well, but generally it's you're talking of a longer period between each of those measurements. So that long-term trending is quite an interesting and new thing that's happening out there. Also being able to share the data easily between colleagues, and I've said here at the last point, analyze anywhere, and we really do mean that from a global point of view. You know, I was on holiday a month and a half ago. One of my colleagues asked me to look into something. I was in Singapore, and I was able to look up on my phone some data at a customer site to help with the analysis. That, you know, that is quite a unique thing that you get with that cloud application. And maybe not appropriate for everyone. Some people do want things locally, but where the cloud's permitted, it seems to be a very beneficial thing.
Yeah, I mean, what I like as well, David, I've been doing it recently, is once you've got some data off the machines, quite a lot of data, and it's run through the different load-ins and processes, you can really set some alarm levels quite nicely, and then trigger off that if they break those alarms, to send you a nice email that basically says, I've got an alarm here, you need to come and have a look at me. And it just makes your job easier, really. and you're just covering the assets more than, like I say, going back to that once a month, collect the data, and then you don't see it again for 4 weeks. So, yeah.
Yeah. And then sort of just on the whole, how does wireless and cloud actually fit into the existing condition monitoring world? Raised a few points here, which I've always found when speaking to people at either CBM conference or something like that, or people who've gone through some of the Mobius training programs, is that actually the wireless side of things is bringing condition monitoring to a much wider audience than existed before. There's a lot more awareness of it in the industrial world than there was previously. We've already talked about how it's complementary to existing products and skills, and what we've heard is that a lot of platforms out there that show the data to vibration analysts utilize some familiar tools that they're used to. So it's not just completely alien to them. It's a hybrid, I guess, between the existing way of doing things and maybe the more newer approach.
Yeah, I mean, in your title there, we've got a bit of revolt, and in certain areas, I've definitely seen a bit of pushback. But I think what it is there's a lot of companies out there that are data companies, experts in data, and they've seen this and only recently got on the condition monitoring reliability bandwagon, and then they're coming into this market, but they're not got any real knowledge of the machines and what's really required to measure these machines. And that's when we jump back to this. We can now see the high frequencies where some of the stuff that's being pushed is really quite low frequency. And if you're not a vibration guy, you're not going to ask that question. Oh, it's just, oh, I'm doing vibration. This sensor does vibration, but vibration is not like temperature. There is, as you know, David, there's so many different parameters. It's a soup of information that these key parameters we can pull out of it that mean a lot of different aspects to how you monitor a machine. And that's my concern. And I think that's why in some of the areas, I think I've seen some pushback because of these companies really sort of not understanding what's really required to monitor machines. I mean, I've seen some places where things were put on sort of 1-2 RPM machines, and you just know you're not going to get the good data. But the customer doesn't know because he's not a vibration expert. So you've just got to be a bit aware of that.
Yeah, even things like the mounting of the sensors. I'm sure we've all seen pictures on LinkedIn. I know I see them on a daily basis where these sensors have been mounted in some rather unusual scenarios, or an insufficient number of sensors to actually cover large machines and things like that.
No, it's absolutely key. It's any vibration analyst, when you start doing the training, it's all about getting good quality data, and that starts with, like you say, the mounting method, the location of the sensor. And that's another thing you see again, people trying to save money. You might have a 300 kilowatt motor that's probably got 3 or 4 foot between bearings, and there's one sensor in the middle of the motor. It ain't going to work well. Yes, it might when that motor's about to fail and shaking it to bits, but you're not going to pick up the subtleties of an early bearing cage fault or that. It needs to be in the right location. So
yeah, and it's also, you know, a lot of companies are trying to bring in trying to utilize data science where possible, and be honest, there's some people doing some really interesting things in the industry around data science and AI. The way I've always seen it is that it's there to help the vibration analyst guide them towards the faults. And I'm sure you would agree with this, Stuart, but it's, you know, anything that helps with that is great, but it guides you towards it, and it still requires the vibration analyst experience.
I'm sure down the road, this technology will get more and more accurate, but for me, you still need a competent person to be looking at this data and making the decisions, looking at the loadings, the process side of it as well. And I think it's a bit naive to think you could just let the machine tell you exactly, oh, I've got a ball spin fault and the cage fault's going there and it's going to fail in 4 days. I mean, yeah, think we're a way off that yet, to be honest. So yeah, a lot of these systems for me, absolutely fantastic, but you've still got to have that human interaction with that decision process, basically.
Definitely. So I guess getting into it in a bit more detail, we have some case studies prepared that Stuart is going to run through. Stuart, if you want to take it away.
Yeah, I'll let you know when I want to a different slide. So yeah, this was an interesting one. This is a fan at a power plant. That we were doing a bit of a trial really with the wireless, and basically, if you go to the next slide, David. Wait for that to change. Yeah, there we go. So yeah, this was on a power plant, a fan, and we only had a couple of sensors on the fan bearings. We were doing a trial with other sensors elsewhere. Normally, if we were monitoring this, we'd have sensors on the motor as well. But we were just looking at the fan bearings. So if you just want to go to the next slide, David, please. So this is some trend data, basically, off this fan. The velocity RMS values are at the top, and then one of my favourite parameters for looking at impacting type problems, bearing defects, this type of thing, is in Gs, monitoring the waveform peak to peak. So you can see there we've got quite a few months spanning. Now what was interesting here is that you can see the peak to peak trend at the bottom picked up, starting to get some higher Gs on this fan bearing drive end quite early. And it was one of my colleagues actually put a request in. As you can see, it broke the alarm levels on the peak to peak. The levels were getting quite high. I think we're up to 30 Gs there. And we requested them to change the bearing. Unfortunately, they really didn't want to shut it down because of the power plant. They couldn't turn it off, so we just basically kept monitoring it. So this one went way beyond where I'd normally pull a bearing, and you can actually see in the velocity trend towards the end, we start to get really high levels now. We've got looseness there as the bearing starts to go. And actually at the bottom, the peak-to-peak waveform trend, that's quite typical actually, where when you get a fault that progresses from, say, a normally spalled bearing to actually the clearances have gone and it's starting to fall to bits, you will actually get a reduction in the G's vibration. So there's a good sign for you actually that this thing really does need to be looked at. So if you go to the next slide there, David, I think we got some temperature data as well on that thing. Now they're the power bands, just looking at the individual power bands. If you go to the next slide, David. Yeah, there's some historic spectrums, and you can see we've got some higher frequency energy there, and you can see it's progressed from some actual peaks to just a noise floor basically because this bearing is in quite a bad way. Next slide. And there's the delta 10 temperature. That's quite nice. We're looking at, I think, from the gateway temperature to the sensor temperature, so it takes into account the ambient, and you can see there we have quite sharp increases of temperature as well. And then I think so the last slide.
Delta temperature, sure. So that's a delta between the ambient temperature in the plant and the sensor itself.
Yeah, yeah. Next slide. Yeah. So I think that's just a spectrum and waveform there. You can see we've got a time waveform. It's a bit cut off there, but we've got quite high Gs on that, peak to peak of 32 Gs there. So quite a well-developed fault, not looking good. And then I think the last slide, we've got a picture of the bearing. It's on the shaft.
Not on this one. I think on this one you have the picture of the bearing.
You took the best bit out, David. Trust me, everyone. There was a picture of a bearing there with rollers dropped out. So yeah, that was a pretty bad one, really. So like I say, we're left in way too longer than I would have. It didn't damage the shaft, fortunately, but the bearing was in the right, not a good state. So this next one, it's another bearing defect, but this one's quite interesting because this was like what I mentioned earlier. It's done on a routine using traditional vibration. So the site team go around every 4 weeks. They collect data on this machine, and what it is, we go to the next slide. So it's a shaker screen basically. So it's got a drive motor and then 2 gearboxes. There's eccentric weights in there, and this is vibrating like 200 millimeters per second. So when you put your sensor on there, you get quite a high vibration level. But as we know, when we're looking at these bearing faults, we're not looking at the velocity, we're probably more looking at the acceleration in G's. So you can see there, there's actually you can see a traditional fixed sensor there that the guys plug into once a month, and they picked up a bearing defect on this gearbox. Now this is super critical. This is the main feed into this factory. If it goes down, basically the plant's going down, the whole factory's down. So super critical. So we knew we had a bearing defect, and this particular factory only runs for so many months of year. So they really wanted to run this until the campaign was over, which I think was another 3 months. So instead of shutting the plant down, I said, well, you could go up there 2 or 3 times a day with a guy with an analyzer looking at the data. I said, we've got this wireless kit, let's put the wireless on. So we put some wireless sensors on there. And if you go to the next slide, we picked up the bearing defect with the wireless technology as well. And you can see there on the left-hand side, we've got the peak-to-peak G's trend. And over February to April, we had an increase there. But the beauty was, it gave us a comfort factor that we could see the data daily. Yes, it was increasing. We knew it was falling. It was getting worse. But if you go to the next slide, when we looked at the wireless data, we could see it was an inner race fault that basically it wasn't changing. So in other words, I didn't see an outer race appear. I didn't see a cage defect appear. It was just an inner race. So I knew that the inner race of the bearing was probably quite damaged and progressively getting worse. But we had that comfort factor because we had the data to say, you know what, let's keep running with this. I'm not too concerned. If it had shot through the roof and I'd have got like 68 Gs, I would have said, look, guys, you're really going to have to shut this down or you're just going to wreck that gearbox. But it didn't. And if we go to the next slide, you can see here's the progression of the fault. So we've got the 2.5K frequency at the top, sort of a waterfall plot. You can see lots of little spikes with sidebands. This is a classic inner race fault getting worse. And then we've got the 10K, the really even higher frequency plot, seeing we've even got more data higher up. So this is the wireless data. So it's really great data. This is what we see day in, day out as vibration guys. If you go to the next plot, David, please. So we managed to nurse this to the end of the campaign and took the gearbox out, and you can see there was an inner race defect on there. And quite bad spalling, but probably would have run maybe even a few more months, to be honest. But obviously, you've got debris going around the gearbox, just going to start attacking elsewhere. So for us, it was great. We didn't need to put a resource on going up every day. We could just monitor it and just have a comfort factor really as well. So that saved quite a lot of money there, the shutdown. So it was a great use of the technology on a bit of a troubleshoot type problem. Yeah.
And did you find, Stuart, that the understanding then of the vibration and I guess, you know, the outcome was well understood across the plant with who was involved?
Yeah, exactly, because you imagine you're on a site and you've got this fault on the supercritical piece of kit. You've taken some data, say, a few days ago, but then now you're like, what's it doing? But where you've got the wireless data, you can just dial in, have a quick look, see it's there, what it's doing 3 minutes ago. So that comfort level basically gives you the information to make an informed decision. Do I leave it, or am I really going to have to change this? So yeah, it worked really well across the site, and yeah, saved some good money.
Excellent. It's always good to hear like success stories and actually see. I love looking at photos of bearings that have been picked up. I don't know why. It's just it's like the full
vacuum, David. But yeah, I still enjoy it. Like when it's like a little trophy, isn't it? And you go to some of these sites and there's a trophy cabinet of all sorts of bearings.
We do have one last case study. I think it's a relatively quick one, which is an unbalanced one, if you want to talk through this, Stuart.
Yeah, so this one, a relatively simple fault, really, a classic unbalanced fault, but again, a good example with a wireless where we've got this gas fan that's related to a power plant and a big dryer system, so it's part of an animal feeds plant. And basically, we were trialling the wireless. You can see the 4 sensors on there positioned on the asset, the fan, and if we go to the next slide, we basically, they shut down this fan, which they often do with it. It's part of the dryer process on this plant. It's on and off sometimes, and they shut it down. The vibration levels were good. I think it was less than 4 millimeters per second. And then if we look on the right, when they started that fan up again, it was quite high. It was up at 20, so we got an alarm quite quickly. Now, this had only been monitored by the routine team, I think 2 days before this. So on their sheets, it was like, yeah, gas fan's good, no problem. But suddenly the wireless is saying, I'm not happy now. I'm doing 20 millimeters per second. And if we go to the spectral data, I think you can see we've got a high vibration at the running speed. There you see we've got a large spike at 1 times the fan. So what puzzled us with this, I talked to the customer and I said, look, could this have dirt on it? Could it have a build-up? Although we had no trend of that, it was just a pretty instant. I was quite worried because I thought, has a blade come off? Have I got a crack on the impeller here? So I said to them, you really need to inspect this. And they came back and said, well, really, it shouldn't get dirty, this fan light. It really shouldn't. So it made me even more concerned. So eventually, after a few days, we managed to get the fan back down, and if we look at the pictures, they had an inspection inside, and it was absolutely covered with dirt. Have you got that next slide, David?
Yep.
Sorry.
It's a bit slow.
Yeah, there we go. So we've got some before and after, and it was absolutely caked inside. They were absolutely shocked. So basically, we deduced when they'd stopped that fan and restarted it, what we think happened was, because they inspected it for cracks and they were absolutely fine, that maybe a chunk of dirt had come off the impeller and basically just sent it out of balance, basically. So they give it a thorough clean, and away they went. But they were then now looking into why there was dirt build-up getting in this fan as well. So now it's sort of led on to other investigations on the plant, because it really shouldn't be getting dirty in there. So again, if we'd just been doing those monthly readings there, which they were, if we didn't have wireless, that could have been absolutely hammered for at least 4 weeks, might have even led to a bearing failure, some other problem we wouldn't have known. But the wireless picked it up there and then. Like, so we can see there the before and after when they cleaned the fan, and then it actually, you can see on the data, it's actually better than it's ever been. It was down at 1 millimeter per second after the clean. So yeah, really good data.
Yeah, I think this is a really interesting one, Stuart, because we've worked with a number of customers in North America, particularly waste and recycling facilities, who use the vibration sensors. They use it for predictive maintenance too, but also for process. And they had lots and lots of fans that would get dirty from time to time, and they didn't know when they would have to go in and clean them and stop them. And they were actually using wireless vibration sensors for that, so they could see the trend building up. There was dirt and stuff getting on these fan blades, and then once it got over an alarm limit, they would go clean it, they would see it come down, they'd get the feedback as well to say, yeah, okay, it's all good now.
Oh, no, it's an excellent way of doing it. And again, I was on site 2 days ago, and these unbalanced faults sometimes, if a certain type of fan bearing, especially these plumber block, they really don't like it when they get raised levels of unbalance, and then it can lead quite quickly to sort of like looseness, fretting problems on the bearing. So if you can, like you say, use this technology to pick up these problems early, get it cleaned early instead of letting it hammer it for a month or two, yeah, the reliability of your assets just increase because you're just not having to repair them as often.
Yeah, that's the end of the case studies, and now we're on to answer any questions that you might have about any of the case studies or anything that we've discussed today at all.
Perfect. Thank you guys so much. This has been a really insightful conversation. It's so much great to get the perspective on both sides here from you guys, so we really appreciate that. As David mentioned there, it is time for our question and answer session. So if you do have any questions, go ahead and enter them into the question panel if you haven't already. We will get as many questions answered live here as we can today. And if we don't make it to your question, we will pass them along to David and Stuart so that they can answer them for you in the coming days. All right, so we did have some questions come in while you were presenting, and I know that you touched on early in your presentation about the limitations of wireless sensors, and we had a few questions come in asking about security concerns, and specifically with the IT department. Do you happen to have any insights on how to manage a workaround with IT and help them get on side with wireless?
Yeah, it's a really good question. It's something that we discuss with customers nearly on a daily basis. One thing that's really interesting to me is you can actually never tell whenever you go into an organization how strict their IT policies are going to be. We've gone to some facilities that would appear quite secure and takes a lot of effort to actually get on site, and actually their IT policy is relatively sensible, and you go to other sites that maybe manufacture something that seems relatively mundane but have very strict IT policies. And the way that we do that is we work very closely with our customers' IT teams. We would generally have a lot of documentation prepared which explains the different aspects of security from all the different stages of the technology that we would use. So if you think about it, there's different interfaces between the sensor and the receiving device, and then between the receiving device and that data going through their network, if that's the route that it's taking, up to the cloud. And so we have very clear documentation on how you approach that, and we work very closely with customers to get through those issues. Some customers do have concerns about data going off-site, and we work with those customers very closely as well. We explain what the cloud technology is and how it's secured and isolated between customers and things like that. But for some customers, there's other opportunities to maintain the data locally on-site if that's the route that they want to go down.
Excellent. Thank you so much for taking the time to answer that question for us, David. We'll go ahead and move on to the next question. This one has a little bit of context with it, so I'll go ahead and kind of read it verbatim. Our group takes route-based readings for a variety of reasons. One main reason is to gather the data with the same method and set up every single time for repeatability. One of the concerns we see with wireless is a lot of variables being added into the vibration signal, such as tapping, drilling, milling, etc., which would be harder to diagnose why the overall levels may have increased. Do you have any helpful hints on analyzing the data to alleviate these issues?
Stuart, do you want to take a shot at that?
Yeah, I'm a bit puzzled on that one. I need to listen to that one again. Sorry. Could you just
No, that's
repeat?
okay. I can go ahead and kind of sum it up. So one of the main concerns that they're seeing with wireless is that they have a lot of variables being added into their vibration signal, things like tapping, drilling, and milling, which makes it harder to diagnose why the overall levels may have increased. Do you have any helpful hints on analyzing that data to alleviate those issues?
I'm just struggling with the tapping and drilling. Is that from like the process?
So I think it's another process, Stuart. So there's where they have whatever they're monitoring. There's other vibration signals coming into the could be heard by the vibration sensor.
Yeah, I mean, the wireless is, in some respects, like David said earlier, it's no different from doing your traditional vibration. You're still going to have those same analysis issues, and I guess what you've got to identify is that other process that's transmitting onto the machine, that you've got to sort of split that out in your spectrum, maybe with power bands or something like that. So you're not just looking at an overall, you're splitting up that frequency spectrum into different frequency bands that some of those may eliminate those impacts in there. And I guess another thing as well, we see, yes, you might be having some transmitted vibration in there, and with the process you'll get a trend, a band. It might not be a lovely smooth trend, but it will be within a band, and then when you get a further fault, it's going to come out of that band and go higher. So you could set your alarms on that. But yeah, it sounds to me like more just typical analysis, really trying to decipher different frequencies out of the spectrum and that. But maybe the power bands is a good
Yeah, I think as well, Stuart, there's some tools will be available there, either low pass or high pass filters or band pass filters.
Yeah.
If there's something happening at a specific frequency, to help you, I guess, ignore if you know what's going on in those other processes.
Yeah, there's no doubt though it is a challenge if you've got something causing a lot of input on there that's like a process. It can swamp some of the data. It would be quite challenging, that, I would say. So.
Excellent, thank you guys. Our next question is asking about the frequency range, and is it the same for all axes?
So I guess it depends which sensor you're using. If you're using a Sensoteq sensor, all of our sensors have the same frequency range on all three axes. It's always adjustable as well, so you can adjust it based on the application. So some applications, as Stuart was talking about, maybe lower speed applications, you'd focus more on a low Fmax but a longer time waveform, for example, and you might do that on the Z axis or something like that, and ignore the other axes. But essentially, yeah, with the Sensoteq sensors, all three axes have that same range.
Perfect, thank you. And thank you to everybody who is submitting questions for us to answer here. If you do have remaining questions, feel free to continue to enter them in. We're going to wrap up with one last question today live, and then we will pass along any remaining questions for these guys to answer for you. So the last question is asking about the implementation process when you're implementing wireless sensors. Do you start small or do you overhaul?
I
suppose that's a mix between me and you, Stuart, but
I'll dip in on that. I'll dip in. What I'm seeing out there, there's no doubt fully kitting a large site out with any technologies is a substantial cost to it, and some of that is occurring. But my feel is, my insight and my talks with customers is a lot of people are really interested and they're dipping the toe in. So what a lot of sites are doing are getting just initially some sort of like using it for a little bit of troubleshooting just to get comfort with the technology. So they might even use a bit of like the technology and rove it about. So they'll have the traditional VA routes, and then they'll highlight a couple of problems, say, do you know what, let's put the wireless on that, and then they'll get a real insight to these faults. So we're seeing a lot of that, and then from that we're seeing sites just building on it really. So sort of, I would say generally starting small and building, but that's not to say there is some that have gone, right, this is the strategy we're going from. It's come from the management, top-down directors, and said we're going to implement this. That does happen. But generally, I would say at the minute there's a lot of interest and people wanting to get a comfort in the technology, which is a great way of getting into these technologies. And the beauty is you can just build on it.
Yeah, I think it's quite a pertinent question for the title that we have today, which is Revolution or Revolt, and that's exactly how it is for some people. With the companies that are very tuned in to vibration analysis and predictive maintenance and have a wider predictive maintenance strategy, we find those are the ones that typically adopt it much faster. And I would say having that expertise really does help with understanding how fast you roll that out, which machines you roll it out to, how many at a time, etc. But for most people as well, you know, if they're concerned about the technology, then doing what Stuart suggests works really well too, just to get familiar with it as well.
Yeah, just getting that comfort with the data, and definitely.
All right, thank you so much, guys, again for being here with us today. Before we do wrap things up, did either of you have anything else that you would like to add?
Just to everyone, thank you for listening to us today, and hopefully you found it interesting. If you do have any further questions for myself or Stuart, we'll be happy to answer them by email or however that might be. Stuart?
Yeah, no, thanks a lot, everyone. I've enjoyed that, having a chat with you, David. And it's always great to talk about new technologies and getting them out in the field and seeing some more case studies and picking problems up. So, yeah.
Great. Thank you both, David and Stuart, for your time and for this great presentation. Your conversation was very insightful. And on behalf of the entire team here at Mobius Connect, we also want to say thank you to our wonderful audience for joining us today. And just as a quick reminder, the recorded version of this webinar will be made available on Reliability Connect, and you'll all receive it in an email tomorrow as well. You can see a full list of upcoming webinars and other educational content on Reliability Connect, which you can visit directly at reliabilityconnect.com. And if you are interested in engaging with other industry professionals or would like to participate on the industry's live feed and ongoing forum discussions, you can do so by visiting Mobius Connect at mobiusconnect.com. You can also follow us up on social media at Mobius Connect to stay up to date with all the latest community happenings. And if you do have any questions at all, you can always email our team here, info@Mobius Connect. We will pass your information and questions along to those who can answer it. So thanks again for joining us today. We hope you all have a great day. Please stay safe, and we will see you next time.